Okay, I'm launching again.
Hello?
Okay, it seems that we're live now.
Okay.
Ah,
Sorry for the little technical issue. The software we're using for the streaming sometimes has some hiccups. We're gonna wait a couple minutes just for everybody to join to confirm everything is good. Okay, I confirm the stream is on.
let's go.
Yes. Okay, then let's start slowly when people join. As always, feel free to ask your questions if there's any. So today the goal is to go a bit through quite a few things. First, to go do a little retrospective on a little debrief on the bug we had on October 5th, so a bit more than a week ago. And the idea would be that I show you exactly what happened, how we managed it, the decisions we took, what went well, what didn't, the lessons we took from it. And I will do the technical part. In the meantime, Sebastian will tell you more about the
Yeah, what happened on the market side, like the
exactly, yeah.
exchanges and market making.
Exactly. So everything related to the market, some measures taken by the foundation for the future, and also some news from the foundation for the future as well. And on my side, I'm gonna finish with some news on the deeper, longer-term projects that we're working on, and I have some exciting news to share with you. Hello. Okay.
So you want to share a few slides?
Yes, I'm gonna share a couple slides if you can do that, Kevin. Perfect. Hi everyone. So the goal today is that I'm gonna start with a technical debrief of the October 5th issue that we had, the bug. We're gonna do a little retrospective, a little debrief. So I'll tell you in advance, the reason why it took us so much time to fix is because it's a very subtle, very intricate, very corner case, complicated problem. So get ready for, I will not get too deep into it, but at least I will give you a bit of a summary for you to understand exactly what happened. So first, I remember on Saturday 4th, 2025, uh, I, wa- I was on the weekend. I took a little break for once because I worked hard the week before. I just took a little break. I was in London. I went to visit some monuments, and I was at the monument when I received an alert. 40% of the nodes went down. So I ran back to the hotel, and from the hotel, I took a computer and I started working, figuring out what's happening. We managed to restart nodes to recover quickly from it, and things went back to normal after restart. So we had a look at the many of the statistics. We have a lot of metrics on some of the nodes we have, and we can see almost everything, at least for the nodes we control, which are very few, but at least it gives us an idea. And what we saw was this yellow thing here. So what you're seeing here is the number of final blocks, final slots actually, executed per second as a function of the date and time. So you see that during Saturday 4th, suddenly everything was going fine, and suddenly we had this dip. The green ones are slots that contain a block, and yellow ones are slots that are executed but that do not contain a block. They're misses. And suddenly we saw that around Saturday here, around noon, exactly when I went out, of course, we had a dip here. What happened is that many slots were taking didn't contain any blocks for some reason. That's one observation. And also, as you can see, it dipped quite deep here, which means that uh, it took a lot of time to execute some of the slots. Normally, Massa runs at 2 slots per second. This is the normal baseline. If we're late a bit at some point, we're gonna catch up just after, and that's fine, that's normal. What we observed here is that we were late for a prolonged time. Slots were executing too slowly, and this was one of the symptoms. Then we looked into about 50 gigabytes of logs because we log everything. We went through everything through the logs, and in these 50 gigabytes, we found that the nodes were using unusually high CPU during that time. So it was not some kind of deadlock. It was literally something being executed. It's weird. And we also observed that the network was forking. There were many cliques. This was quite surprising. Eventually, the network recovered and stabilized. That's quite surprising when you think about it. Of course, it was in the middle of the weekend, so we were focused mostly on fixing the issue at hand and extracting all the information so that we can solve it during the week. So we checked up everything. Everything was stable again. We didn't know what happened, but at least we gathered all the data. We saved all the snapshots so that we could run some deeper debugging during the week. Comes Sunday 5th. Everything was fine. Everything was stable. So I was like, okay, I'm gonna finally be able to take some rest. So I went out again. And as soon as I went out, literally, the network started massively forking, becoming increasingly unstable. We tried to do the same reset we did on Saturday, but this time it would desync almost immediately after the execution. Basically, we saw that the network was literally fighting very hard to keep in sync, but somehow every single node was trying to create a fork on their own. We didn't understand what was going on, and this resulted in the general outage that you observed. So of course, I ran back home. I pulled out the computer and we checked again. And this is the Saturday issue, and this is the Sunday issue, the right one that you see here. The Sunday issue was way more catastrophic than the Saturday one. It was the same symptoms, many clicks, high CPUs, very long slot execution times, but this time it did not recover. It didn't recover in time, and the network literally crashed at this point. So we had a bug or an attack or something, we didn't know, but we have all the logs, we had everything. So we immediately started working on trying to fix the issue, trying to understand what was the underlying problem. And many of the statistics we observed didn't show, actually it showed that all the modules were panicking in all directions. It was extremely complicated to understand what was going on. It's like a generalized bug in the whole node. But this is surprising because everything is audited. It's quite sturdy. It's actually quite heavy, battle tested, and we tried everything on it. So it was quite surprising. And this statistic in particular was interesting. This is the asynchronous message pool. You know, in Massa, we have these autonomous smart contracts that execute on themselves, even if there's no blocks. And we realized that this was the size, the number of transactions that were autonomous and that were about to be executed, waiting to be executed, had spikes exactly on the moments of the crash. So you see that's Saturday, that's Sunday. Sunday is here, and actually Saturday, if you look closely, it's this thing that correlates perfectly, like the little bump here. So this was interesting. It was surprising to us because it means that maybe something related to autonomous smart contract was the issue. But to me, it didn't make any sense because why would it create forks in the network? So we dug more into the logs. Some sleepless nights there. And we found a few things. We found these logs that you can see here. And it shows that some autonomous smart contracts were executing. And this slot in particular, with all these little things, took 60 seconds to execute. A normal slot in Massa cannot take more than 300 milliseconds. This one took 60 seconds. So there was obviously some issue here. We looked into it closely. We scanned it a bit. We looked and we saw this stuff here. In this slot, there was a block, but the block did not contain any transactions, so any operations. So it was not the fault of the block. It was also not some kind of deadlock because CPU was 100%. So literally, these autonomous smart contracts here were doing something weird. And when we looked into the messages they were saying here, they were saying something like transfer success, next scheduled for period whatever, next autonomous smart contract schedule here, some kind of swaps. And this whole thing behaves just like some kind of autonomous arbitrage bot. So somebody had deployed a very heavy autonomous arbitrage bot on Masa that works autonomously on the network using the autonomous smart contracts.
Which is good.
Which is very good, which is nice. Kudos to them. But somehow they hit some kind of corner case that we didn't see, that our developers didn't see, that our reviewers didn't see, that our testers didn't see, that the auditors that we paid did not see. Somehow they hit some kind of special corner case that went through all these filters that we put in place. So we have to understand what's happening. So first of all, my first question was, okay, fine, the slot took 60 seconds. So normally, this is how the modules in Masa work. We have let's start with the consensus module. The consensus module takes blocks coming either from the network or from the block production inside the node, and they arrange them inside a graph. And inside this graph, the only output of this consensus module is to say, okay, among these blocks, here are the ones that we're gonna execute. Here are the ones that are become final. That's it. For this, once consensus, I forgot a line here, but once consensus has agreed on a set of blocks to be executed, there is an arrow from consensus to execution here. Consensus tells execution, here is the list of blocks to be executed. And execution is a module that is completely separate. It runs in a different thread. It takes the list of blocks to execute, of slots actually to be precise, because we don't need blocks to execute stuff in Masa. And it starts executing them one by one. And the execution runs linearly here until it has executed all the slots. So normally, what happens if execution takes too much time? Let's say one slot takes 60 seconds, what we observed. What happens is that execution is late, but it should not have impact on anything, except if the lateness is too high. It happens that execution also feeds the proof of stake mechanisms, which selects who's supposed to produce a block and when. And it happens that if execution is too late, like I'm talking almost an hour late on the current time, then execution is supposed to feed snapshots on who has how many roles to the proof of stake mechanism. And the proof of stake mechanism is used by the consensus to know who's supposed to create a block at what time. Because if we receive a block that's not supposed to be produced by that person at the time, we should reject it. So we need this. And if we don't have the latest draws for the proof of stake when we need them, which is for the consensus typically, we basically kill the node. So what we expected is simply that, okay, if execution was really just late, it should have just eventually caused proof of stake to be desynchronized. And therefore, consensus would detect this and the node would crash with an error message that states we could not find the proof of stake draws for cycle something. But what we saw was, okay, we saw that, but what we saw was way more complex. We saw that the consensus itself was panicking. All these modules are supposed to work asynchronously. They're not supposed to wait for each other. It's massively parallel architecture. We worked a lot on this. This consensus module here is not supposed to wait for execution or something like this. It's supposed to just move forward. It's only if proof of stake is super late by an hour or something, then it crashes. But otherwise, it should work. So why did we have so many forks, cliques? What happened there? And the answer was quite complicated to find. It took us a lot of time, and we did not want to restart the network without being sure we have fixed the problem. So, okay, fine. In execution, there was something causing a long execution of slots. But there was something more here. Remember, your node is also supposed to be able to create blocks, right? And when it creates a block, what it does is that it asks for the pool of pending transactions for a nice set of transactions to include in the block. It adds also some endorsements, it adds some stuff. Before all of that, it has created the header. And once it has assembled the whole block, it also it sends the block to the consensus. For it to know when to create a block, of course, it's also asked the proof of stake, am I supposed to create a block here? Obviously, this is not a critical module in the sense of if it doesn't have access to the proof of stake, it just emits a warning about this. It just doesn't create the block. It doesn't crash. Consensus does. So by looking into it, we realize that the problem comes from actually the pool here. The pool is basically the list of pending transactions. When somebody emits a new transaction, they say, okay, here, I want to spend that many coins from my account and send them to that person. I'm going to pay that many fees. Obviously, this transaction is not executed right away. It first is sent to the pools. It propagates through the network, and the nodes store them in the pools. It would be too easy to attack the network if you could just declare that you can send many transactions. So we have this kind of priority system where the pool actually prioritizes transactions with more fees. If the blocks are full, just like in Bitcoin, Ethereum, elsewhere, if the blocks are full, we have to prioritize transactions with more fees. If the pool is full of pending transactions, we're gonna drop some low fee transactions and allow some higher fee transactions to come in. We're gonna make space if necessary. So this is how the pool works. But there's a problem here. If you just leave it like that, somebody can just declare, pretend they're gonna pay a lot of fees, but actually they don't even have the money on their account to pay for these fees. So that's a typical attack that you can do. That's why our pool has a lot of security here. It's gonna actually ask the execution module to check whether the person pretending to be able to pay all these fees to be prioritized in the pool actually has the money to do that. And here we had omitted, there is one blocking line. The pool is gonna actually wait for the execution to respond, right? For the pool to know if the person has enough balance. We thought it was not an issue because if the pool waits, it's fine. Okay, the pool is gonna be a bit wait. We're gonna have a bit of inaccuracy in the transactions we're gonna include in the blocks, but it's not the end of the world, right? But here is an interesting chain reaction that happened. Remember, execution was executing a slot that takes too much time, 60 seconds. During all that time, it kept a writing lock, a unique lock on the state. So nobody else could read or write the state because this guy was writing it. And when the pool tried to ask whether a certain person had enough coins to pay for the fees they pretended to be able to pay, well, they could not acquire a lock on the execution state because it was being written to for 60 seconds. So it had to wait. So pool waited. It waited, and while it was waiting, it kept a write lock on the pool itself, on the list of transactions. Why? Actually, to be precise, no, sorry, not even. It kept a read lock on the pool. Now what happened? It's something called integration hell, because so far everything is designed properly, right? And the block factory, the module responsible for creating the blocks, it was the way it worked is that first it's gonna ask the proof of stake, is it my turn to create a block? Yes, no. Oh, it's my turn. So I'm gonna start by creating a header, choosing the parents of the block. Then I'm gonna ask the pool for a nice list of transactions with a read lock to include in my block. The reality it's a bit more complicated because it's not a read lock, it's a write lock, because once we include them, we don't want to include them again if we have a block just after. So we have a system that removes them from the pool. So Block Factory already created the header of the block that links the block to its parents. And then it was waiting for 60 seconds for the pool to respond. Because remember, the pool was locked for 60 seconds. And the pool took 60 seconds to respond with the list of transactions to include in the block. Eventually, it responded with a list of nice transactions to include in the block. But by that time, the block that's been produced, okay, it has good transactions for now, but the parents that were chosen for this block, they date back from 60 seconds ago. And remember, in Massa, we have 2 blocks per second, which means that we just ignored all the blocks that were just before us for like many iterations. So we just created the fork because we created a block that has, okay, new transactions, but very old parents. And we emitted this, completely ignoring any blocks being produced in the meantime. And the result is that when we finally sent this to the consensus saw that we created a fork because there was many things happening before. And we just forked back from 60 seconds ago to create somehow a new block. And all the nodes were doing that, all together at the same time. So all the nodes were creating forks. And consensus got overwhelmed. It could not achieve its goal, which is to achieve consensus. He was trying to find the cliques to figure things out, but it didn't work because everybody was producing blocks and not listening to the others. There was literally no consensus between the nodes. So
there is some tolerance, like 15 seconds of delays, like around this time would be fine if you create your block too late, but 60 seconds was way too long, and it's even larger than the time between 2 blocks in the same thread.
yes.
So someone would have created another block in the same thread before.
So the system is made to tolerate, you know it. You can literally run it on the phone. It works. This system is created to be extremely robust to having a very wide set of pretty bad unstable nodes. What he did not expect is that somehow all of a sudden all the nodes decided to fork. That's something we cannot, not a single consensus mechanism can handle.
So that's 2 problems.
Yes. So we have 2 problems here. We have one in the execution. Why did it take 60 seconds to execute in the first step? And second problem, we should remove this correlation here somehow. Okay, because we got each module audited separately and we audited themselves, tested them. The pool works really well, and it's okay if it's a bit late, it's fine, you know. The block factory works really well, and it's okay if it doesn't produce a block, whatever. All this is good, but there's something called integration hell. And these things work very well by themselves, but somehow when you connect them, there's this very special edge case that backfired on us this time. And it was extremely painful to diagnose because all the modules were in full panic mode. So the logs were full of panics from all the modules. We had to filter through 50 gigabytes of logs. So there's a few questions here. So could someone use the pool to make a front-running attack? Actually, well, you can always look at what's in the pool, right? And as in every blockchain, essentially, you can look at the pool, and if there's something you want to flood or something, you should flood it. You can. The thing is that it's gonna cost you a lot, and after a while, you will not be able to kind of push that too far in the time. At some point, it's gonna go through. That's the design of Bitcoin, of Ethereum, of Massa. It's typical on all blockchains that follow this thing. So can you front run in Massa? In practice, in theory, yes. In practice, it's a bit harder than other blockchains because there's 32 blocks being created at the same time, so you don't know what's happening on the other blocks, and we have 2 blocks per second, so it's quite kind of tricky to predict exactly the state of the system in a given time. But can you see transactions before they're executed? Yes. Can we counter this? Not easily, not without sacrificing a lot of performance. Some blockchains have decided to encrypt the pool. They made a whole fuss about encrypting the pool, but honestly, this is bullshit because obviously block producers, who are the ones who are supposed to access the pool, they will still see it. They will still have access to the pool. So they will need to have the special keys to see the pool. Okay, others will not see it, but block producers will. So you just declare yourself as a block producer, and suddenly you have access to the encrypted pool. There are other methods like commit reveal, but these are extremely heavy. So for now, we haven't implemented any protection against this in particular, but we're not the only ones, and we want to make aware everybody that there is, as in Ethereum, as in Bitcoin, there is a risk of front running, but it's more limited on Masa because of the design. Any other questions on this general schematic? Okay, I'm gonna move forward. So now, okay, that's all cool, but why did it execute for 60 seconds in the first place? Well, when we designed Masa, we had to do something called gas calibration. We had to define how much gas each type of instruction in the smart contracts takes. Remember, because we need to have 2 slots per second. So we need to make sure that a slot takes less than half a second to execute, because if it doesn't, we will not be able to keep up with executing all the upcoming slots that are arriving as we run. We're gonna execute them slower than they appear, and this is gonna cause a network-wide crash. So we had to ensure this. To ensure this, we had run something called an automated gas calibration, which means that we have run, we had automatically generated many smart contracts with a lot of different types of calls, ABIs, instructions inside. They're randomized actually. And using them, we have calibrated through regressions, etc., how much time each instruction on average takes in the worst case. So we have taken that on a reference hardware that's not too strong, and we have added some margin, and that's how we have calibrated the gas. So when you use up all the gas in a slot, it means that you have used all the execution time you could have had, and you cannot add more to that slot. You need to send something to another slot. The issue is that we had calibrated in the way I told you, by generating many contracts and by executing them. But it happens that there's some behavior that neither us nor our auditors nor anybody actually expected. It's that under certain conditions, instead of just generating many smart contracts with many calls, you just loop a lot on certain very particular types of calls. You get into something weird that happens only after many iterations of the loop. And it happens that after many iterations of the loop on the same thing, things start to slow down. You would expect the opposite, right? Because on modern CPUs, things get into cache, whatever. It's supposed to accelerate over looping, right? We did not expect that at all. And it happened to slow down over loop iterations. And that was very mind-blowing for us. What's happening? So we dug deep into this. That was also hell. That was also sleepless nights. We found that there's very interesting behaviors. First, with atomic locks. Atomic locks are when you have to access a resource that's shared by multiple CPU cores. And it happens that atomic locks, they behave very weirdly with the cache on the one hand, and on the other hand, they lock temporarily all the cores of the CPU. And it happens that here we had quite a few atomic locks. And by executing them in a loop, they were somehow acting on the cache. I don't know exactly the details of the cache of each type of CPU, but at least in the CPUs we had, it seemed to actually break down the cache behavior and bring it the opposite way. The cache was causing more time to be taken than less. Another thing was we had a hash map access. For those who know what it is, I'm not going to enter into the details, but in Rust, hash maps are protected. They have a safety feature. They use random number generators to avoid everybody having the same hash table everywhere in the network. So after a while, after a lot of accesses to the hash map, at some point, the RNG of the system was drained, and it was waiting for more random numbers to be generated. It was also doing some hashing that was not cached well because of the atomic locks. And finally, all these interacted really badly with the fact that the way it works is that the smart contracts are compiled by something called CraneLift on Masa. It's a compiler. They take the WASM smart contract and they compile it to native assembly on the computer. But remember, we need to keep determinism, which means that all computers need to execute exactly the same thing and stop at exactly the same amount of gas. So before it compiles, the WASMer system takes the original WASM code, and before it compiles, it inserts in it a lot of probes to follow the gas usage over the execution. And then it compiles this, so that everybody, despite their local optimizations, ends up using the same amount of gas. So we achieve determinism. The problem is that whenever we did something called an ABI call, which is when a smart contract calls a function that is on the host side, not inside the smart contract itself, well, WASMer knew that in that cases, this metering on the gas usage could be accessed by the host because we're giving back time to the host. And it happened that this overhead really didn't interact very well with the rest. And as a result, we had a 200 times overhead on the execution on something we did not expect at all. And our auditors did not expect it. Nobody expected it. This is something completely new to us. This weird interaction between all of this together. So we found the problem. We fixed it. We did 5 times on the gas usage of some ABI calls. Beware builders, for some of you it might be a bit breaking, so please be careful. Have a look into this. Some ABI calls now take way more gas to execute. That's a safety measure. We took some margin for it to never happen again. We added a lot of warning systems for any kind of long slot execution. Here also in the execution system, we removed a lot of locks. We removed all the many of the atomic locks. We removed all the hash map accesses, and we optimized gas access. We also implemented a much bigger fix, which is, remember this. So now I explained how we fixed the 60-second problem. But remember, we had this correlation here that if this guy takes too much time, these guys should not be impacted, and yet they were. So we had actually a fix for that as well. We looked into it closely. We thought it was too risky to deploy it right away when we fixed this, because it was not audited enough. It was not looked into it enough. It was kind of a critical fix. It's like 1,000 lines of code. So we decided to postpone it a bit. It's not a breaking change, so we can release it anytime, and anybody who can update to 4.1 can take it over. We are right now reviewing it and testing it to make sure that it works. And what it does is that it makes these guys really independent. So if execution takes time, okay, pull might pull for its reading might wait, fair, but it's gonna use a double buffer system here. Basically, it's gonna be a readily available copy of the last version of the pool that the factory can read right away. Doesn't have to wait. And whenever the new version is ready, after waiting for all of this, the pool is just gonna swap the 2 versions and make atomically the new updated version available to the block factory. So this is one of the optimizations. Another one is that in the block factory, if by any chance we realize that the pool is not responding in 1 second, we still create the block, but we don't wait to feed it with transactions. That's a second level of decoupling here. And another final warning system is if we detect that despite all of this, somehow block production took too much time, we create a warning, and there's going to be an option to not produce the block. But for now, we still produce it. Yep. That's the whole technical shebang. I hope you understood at least a bit what happened there. It was very hard for us to debug. It was a very subtle, very complicated problem to find, because every module individually was working well, actually. But now it's fixed in the sense that it doesn't happen again. It's running. We tried the incriminated smart contract. We called it, etc. It's it's not causing the trouble anymore.
It's
And we are waiting.
restarted.
Yeah, everything is restarted. The nodes are running again. So if you haven't joined back yet, please join. The exchange markets have restarted the nodes as well. So the centralized exchanges are working. The bridge has been restarted. Everything has been restarted. Everything is running again. We're gonna release a 4.1 soon with this back pressure decoupling thing. We'll tell you more about this, but it's not very critical right now. It's just a safety measure for the future. But now everything is working, and I want to thank first everyone for their support. I know it's been a rough couple of weeks. It's been rough for us as well, but at least we recovered from this, and I hope this gave you a bit of insights in exactly what happened. If you have any questions, feel free to ask it during this AMA or later on the community or on DM whenever you want. And now I'm gonna give the mic to Sebastian. That's gonna tell us a bit more about the bug, but on the market side.
Yeah, I want to tell you more on the other side of the story, because there was a lot of movements on the exchanges, and we had a lot of questions about what's happening. So I'm gonna share my screen. Tell me if you see it, Damir, maybe.
Yes, I see it.
Okay. So I want to show you, this is a BitGet chart for Massa token. And I'm gonna comment a bit on what we have seen around the crash before and after. So before the crash, that was on October 3rd, on BitGet, we saw a very big increase in the price, and it's nothing to do with how our market maker is working. So we didn't know what's happening, but by looking at the chart and the other metrics, we understood that someone bought a lot on the market, and we don't know who. And we saw market buys. So market buys, it's when you really want to buy very quickly, and you kind of don't care about the price at which you buy. So it's a very bad practice, and you should try to avoid it. You should do limit orders instead. So you buy with a maximum price that you allow for yourself. And in a few minutes, they drained the Massa tokens that we had on the exchanges. So as a reminder for those who don't know how the market maker work, it's very simple. They put orders on the sell side, they put orders on the buy side. And when people want to very quickly buy or sell, they will usually first hit the orders of the market maker, which is here for giving essentially a better price closer to the average price. So that was working normally before this. And around this time, they just drained the Massa token that we had, because we had only a few millions Massa on the exchanges. We didn't expect that much of buy that quickly. So after 10 minutes, we put more Massa tokens. We deposited Massa tokens on the two exchanges, but it was BitGet in particular that needed more. And then the price stabilized, which like in the next hours, it had very less volatility. So we know nothing about the buyer or why they didn't do DCA or normal limit orders. They would have maximized the number of Massas they could get with the USDT. But anyway, that was before the crash. So that was October 3. The crash was October 4, 5. Damir, you didn't say if that might be correlated in a way. Maybe yes, because the bot was an arbitrage bot on the smart contract. Maybe no.
What we know is that the smart contract that caused the crash was an autonomous arbitrage bot that was deployed later, so a couple days later.
Oh.
So maybe the reason, maybe this spike inspired that person to
I guess.
create this bot, but maybe it's just completely not related. I don't know.
In that case, it was fast. So anyway, there was a crash in the weekend, October 4-5. The exchanges suspended deposit and withdrawals, which is normal when there is any instability on any network. And they continued trading, so we could still buy and sell, which is also usual. So the market was smooth. We just saw, the usual bots that try to extract money from the market. So they make little bumps like here, but that's usual. So we had enough liquidity until Wednesday, October 8, when again someone played or whatever with the market and bought a lot of Massa again. This time though, the market maker was drained again because I only brought a couple of millions in between. But we could not deposit more Massa because the deposits were suspended. So the price went out of control on both exchanges until Friday evening on MEXC, and that's when they reopened deposits. And until Saturday on Bitgate, I think that's when some people dumped around here, which gave more Massa to the market maker. So from then the market was back into not control but less volatile state. And Bitgate reopened deposits a bit later between Sunday and Monday. So then we could deposit more later. And now everything is back to normal. So smooth market making, no big spikes. And now we could handle a bit better this kind of market buys with this kind of amounts on the exchanges because we deposited more Massa tokens. I also want to address the confusion we've seen around the circulating supply. So when we deposit these Massa tokens on the exchanges for market making, you can see an increase in the circulating supply. This you see it on the Explorer, for instance. And this is not, the circulating supply increase is not related to token unlocks, or not only. It's using a definition from CoinMarketCap that we implemented. Circulating supply is the amount of unlocked tokens that are not in the teams, on the team's addresses. So any unlocked token that we have on Labs or Foundation are considered not circulating. For instance, our staking nodes or the reserved addresses. So each time we send tokens somewhere else, like let's say during marketing airdrops or here on exchanges, this increases the circulating supply. So to be fully transparent, we deposited around 30 million Massa on the exchanges in the last week. And this is corresponding approximately to the increase in circulating supply you see. So now we are around 340 or 350 million Massa of circulating supply. And we needed that amount of Massa on exchanges because exchanges want us to avoid this kind of volatility to happen again for obvious reasons. So these Massa tokens, they sit there in case price gets out of control again. Someone wants to buy 50K very, very fast in a few minutes. So we'll be there to provide liquidity to reduce the volatility. Is there any question on this side?
There was a question about just-in-time compilation.
Just
Uh,
take.
Okay, I can take a quick one. Okay, so unfortunately, just-in-time compilation is not something we can do here because it's really non-deterministic in terms of execution time. We don't know. So what we do is ahead of time compilation. At least we have an upper bound on exactly how much time every execution is going to take. And we can only make better from here. So we calibrate the gas using something called single pass, which is a non-optimizing compiler. And then from there, we actually in practice use the optimizing compiler. So unfortunately, we cannot use just in time here. Another thing I wanted to add is that as the reason why we rushed so fast to fix this problem and took a lot of shortcuts is one, we didn't want to have too long of a downtime, and second, well, as Sebastian said, we were out of the requirements of the exchanges, so we were risking the listing, and we had to quickly act and reestablish the network to be able to reestablish the market maker. So we wanted initially to do a kind of a fair launch in a way, to restart with everyone, etc. But we were not sure it was stable just yet. And when we realized it was stable, we were like, okay, let's just move forward. And we finished exactly on Friday night, exactly the day before the market, the centralized exchange was starting to analyze our token for potential delisting. So it was extremely tricky.
So now market also is smooth again. You will see a bit more liquidity. You will see more massa on the sell side. You will see more USDT also on the buy side. But anyway, that's if you care about the price. And I also have good news for small stakers, because we know that when the blockchain was done, first, nobody could get their rewards, of course. No blocks, no rewards. We also know foundations nodes, maybe labs also, but foundations nodes who are among the first to restart on Friday night. So we got a bit more rewards than usual. And not all small stakers had time to rejoin soon yet. So with the foundation nodes rewards, we want to offer to double the rewards of small stakers who come back to the network. So it's for small stakers who were there before the crash, just before. So we took a snapshot on the previous Friday before the crash, so Friday, October 3rd. And we mean small stakers. For us, small stakers is like below 1,000 rolls. But we will also reward all nodes that are not our nodes in their first 1,000 rolls. So for bigger nodes, of course, it will not be a double rewards in the next 2 weeks. I didn't mention. So we want to double rewards for the next 2 weeks, starting today. We'll give you a bit more details in the next announcement, probably tonight, in case some part of it is not clear. But we hope it will be an extra incentive for the smallest nodes who get a bit less rewards and who still have, many of them have a server cost because they run on VPS. So stay tuned for more information on that. Question about volatility. So to summarize, high volatility is not great from the point of view of the exchange. So when they see it, they ask us to improve the market making. Of course, sometimes you cannot avoid it. In particular, last Friday, so the day the blockchain restarted, if I remember correctly, that night, like all major tokens crashed, and well, it was an opportunity to buy the dip, I guess. Anyway, tell me if there's any question on the small nodes rewards, bonus for the next 2 weeks. Otherwise, that was my main news. On another topic, today also is the last day of the Massa Bits campaign. So we will wrap it up soon and announce the details of the rewards, investing, etc. I think next week we need a bit of time to check everything and that everything is correct and that we removed all the Teams addresses and etc. etc. In the meantime, congrats to those who participated to the Massa Bits program, and everyone will be rewarded. So yeah, stay tuned also for these details. Yes, it's the end of the program today. How about Massa Bits program ending right now? Rewards to come. Stay tuned. Probably we'll do our best next week. What is the time to burn out Massa tokens, please? We got asked about our, let's say, burning ambitions, and we agree we can burn a bit at some point because we don't use all the token that we have on hands anyway. So yeah, sounds good. So we don't have any announcement right now, but we will tell you as soon as we know how to do it, how best to do it, what amounts, what makes sense, and to avoid doing something just useless. So by the end of the year, you will know everything, and we will just do it. Stay tuned on this side also. Now I can give it back to Damir for maybe a few words on the next steps, what product will launch soon, and on what also our marketing will focus on these sites.
Yes. Okay, we don't have much time here, but I'm gonna try to be quick. We can do another session with more details if you're interested. So on the groundwork, remember, like we were starting to build these groundwork projects that are gonna bring you real usage to Massa. So on that side, we have worked quite a bit. Okay, we were a bit late because of the bug fixing. Everybody was on it. We took 1 week just to fix the bug, but now it's better. We're back on track. So there's a few things coming. A couple of them are still under NDA. I cannot really talk about them, but I can talk about at least 2 of them that are very interesting. One is we're creating basically an encrypted chat, something that will allow people to chat a bit like Signal or WhatsApp or Telegram, but it's going to be end-to-end encrypted by default, perfect forward-backward secrecy post-quantum. It's going to be running on Massa as a backend. It's going to be something called sealed metadata. So contrary to Signal, for example, where the server knows which phone number is talking to which phone numbers and what time and what, just they don't know the contents of the messages, but they know everything else. Here, nobody will be able to know who's talking to whom. That's the idea. But it's not going to have a server. It's not going to depend on phone numbers. So all in all, our goal is to have something that looks and feels like Signal, but that is actually safe. And our goal is to push this very quickly before we get trapped by laws like chat control. So as long as we have a bit of freedom of speech, we want to use it and to deploy these things in a way that cannot be shut down afterwards. The idea is to respond to the limitations of the existing technologies. So that's the first things we're working on the Massa Lab side. The second one is that I wanted to mention, and I was supposed to do actually a community call 2 weeks ago, but the bug happened, and I'll probably do it a bit later. It's the transparent bank system. So remember, our goal is to create some kind of banking system, a core banking, where we can actually prove to a smart contract what's happening on the bank account. this could allow a lot of things. It could open the way for like international bank transfers for cheaper. It could open the way for purchasing digital goods without an escrow, like peer-to-peer directly with fiat. All this by using the Masa blockchain in the background. So here we're leveraging our knowledge in machine learning, in AI, and also our background in banking in order to create this. So stay tuned on this. I'm gonna give a bit more details, but it's moving forward really well. Yep. So that's the two main big projects that we're working on, and we hope are gonna bring real usage and not just some kind of temporary pump and dump. We really want to bring like people to use it without maybe even knowing that there's a blockchain powering it. When a company uses a database like MySQL or something, they don't advertise it because they use it because it makes sense. They paid for it, they build it, they use it. Here, we want Masa to become that. People are going to use it when it makes sense. And here is one of the first cases of this. It's going to be hidden. It's going to be not visible, but it's going to be used and it's going to bring value to the ecosystem. Users are going to be paying for these services, and they will not be paying for something they hope to sell later at a higher price or something like this. This is not sustainable. They're going to be paying for something, for a service, and that's it. The money is going to stay in the system. So that's the idea. That's what we're building, and that's what we hope is going to bring value to the ecosystem. And these are midterm, long-term projects. So stay tuned. We're going to continue pushing on this side. Actually, on the encrypted chat system, there's going to be a whole new community being built. So you'll get some very interesting news very soon on this.
So these two interesting projects are in 2026 roadmap. Well, yes. I mean, they're already being built, so 25, 26.
So maybe if you run through the questions, any plan to attract more TVL? Well, we really hope that, for example, the chat app, if there's many users, there's going to be a lot of TVL because there's going to be a lot of storage tokens locked during the time they're used. So this is an example of TVL increase that could be brought by real world usage by people who don't even know there's a blockchain behind it. Can we expect deflation on the Masa token? Well, I have proposed a deflationary mechanism in Masa. Unfortunately, it was not. There was a vote, but it was not accepted. So I accept the vote of the majority. But if you are interested, feel free to amend it or re-put it for a vote. And if the community votes for it, why not? We pray God to achieve your goals and targets. Thank you, Ibrahim. Then what do you think about the game Chrono? Sorry, I didn't have the time to try it. Honestly, I should try it. I was literally overwhelmed these couple of weeks, but I'll be back on track. FBI won't like this. Well, I hope they don't like it. If they like it, means that we're not doing anything interesting.
I'm not sure. Like, you know what they like? They like Tor.
That's
the
Navy.
It.
Actually, the Navy is funding Tor. Are these two interesting projects in the 2026 roadmap? Those are actually, well, we need to synchronize a bit better on this because these are Masa Labs projects, but I think they're not properly from the Masa blockchain projects, right? So I don't know if we can just put them on the Masa blockchain roadmap, but they can have their own roadmaps if you want. We can publish them, of course. We're gonna be working on this.
A part of our marketing and what we do at Masa Foundation will be to help the go-to-market of these products, for sure.
Will the core banking or chat have a separate token? The core banking, it's unlikely because at best it would be some stable coins. For the chat app, for now, we haven't planned any new token for the chat app. It's gonna be leveraging Masa, but to pay fees and to pay for storage and to pay for autonomous smart contracts. But for now, we haven't dug more into the token part of things. It could be an idea, but the idea is that we try to attract people who are also outside of Web3, normal users of Telegram Signal. Many of them don't even like Web3, right? They just want to use an app. So we will try to not be too Web3 centric. We're trying to be way more general with this to onboard way more people. What is the cause of the recent downtime of the Masa Explorer? Well, the Masa Explorer, it does connect to an indexer, which is kind of a history of what happens before, but it also connects to the nodes for the current state. And that part was not working because of the bug we explained during this call.
Okay. We're above an hour, guys. So I suggest you continue sending your questions on the main chats. And any feedback you have also about the down, the crash, and maybe about how we communicated, what could have been done better, etc., etc. So feel free to tell us anything you think about it. And congrats to the team. Congrats to Damir and the developers for being 100% or 200% on it last week. Any last word, Damir?
Well, nothing much. Thank you everyone for your support. It's not been an easy couple of weeks, but we're back on track, and together we're gonna achieve great things. I really believe in this, and right now we're gonna be pushing for these deeper midterm projects, and we're very excited to show you more about them. So stay tuned.
Thank you. Bye-bye.
Bye everyone.